Section 4.2, Measuring Strength of Association with Correlation. A correlation coefficient is a number that measures the strength of the linear association between numerical variables. So the key word here is strength. Now, a correlation coefficient only makes sense if you have linear associations and you have numerical variables. It's represented by the lowercase letter r. These correlation coefficients are numbers between -1 and +1. If the value is negative, then your trend is negative. If the value is positive, then the trend is also positive. If the value is close to either -1 or +1, then the trend is very strong. So again, it's a measurement of strength. So the closer the value is to -1 or 1, the more strong it is. And if the value is close to 0, then the trend is very weak. Another note, and we can't say this over and over again more often in this class, is that correlation does not mean causation. So just because we find a very strong correlation between two variables does not necessarily mean that one causes the other. Remember, we cannot form cause and effect conclusions from observational studies. If your data came from an observational study, it does not matter how strong this correlation is, you cannot infer causation. Okay, what can we use the correlation coefficient for? What does it tell us? Well, one thing we know about it is that changing the order of the variables does not change the r value. So what this is saying is you can switch the x and the y axes and not change the correlation coefficient. Why? Well, changing the order of the variables does not change the strength of their relationship. So an easy way to think of that is it's a relationship. Bob and Sue have the same relationship strength as Sue and Bob, right? Just because you say their names in reverse does not mean the relationship strength changes. You can also add a constant or multiply by a positive constant, and that will not change r. All you're doing at that point is moving the entire graph over or up. Again, the strength will not change. Something else about the correlation coefficient is that it's unitless. It does not have a unit measurement. It's just a number between -1 and +1. And linear, the correlation coefficient only makes sense if you have linear trends. So the correlation coefficient itself cannot tell you whether an association is linear or not. But if you already know it's linear, then R will tell you how strong it is. You need to look at a scatter plot first. First determine if it's linear, then you can use the correlation coefficient to talk about how strong it is. Okay, we're going to do a little bit of matching. We want to match the given correlation coefficients with the correct scatter plots. And I know I can't show all this on my screen at once, so we're going to have to do a little bit of scrolling. I will start with this one though. A correlation coefficient of exactly +1 would mean that it's perfect. It's a perfectly straight linear relationship in the positive direction. So that would be this graph right here. It can be modeled by a perfect line. So that would be this one. I'm going to do a little bit of scrolling here. My next correlation coefficient is 0.98. So we want a very strong linear trend, very strong. It's very close to 1, but not quite perfect. So given my options here, I think that would match with this one. It's a very strong positive trend, although not perfect. Okay, and then my next one is a 0.72. So I need, again, a fairly strong positive trend. Looks like my other two positive ones are here and here. Out of those two, I would probably say that this one is stronger. There's less vertical spread in this one than there is this one down here. So I would label this one as a 0.72 and this one as a 0.48. So all those are positive linear trends. The only difference is how strong they are. Okay. Now I'm going to start from the other end. I've used all of these now. I'm going to start from this end. Where would be my perfect negative trend? Well, that would be this one, very bottom one right here. It's perfectly negative. Okay, then I've got a couple other negative ones as well. I need to do, I've got a very strong one and a very weak one. So I think that's these two, my next negative ones. Stronger would be this one. There's less spread in this one. And this one would be the weaker of the two. And that leaves me with an R value of 0 to attach to this one. R equals 0 means there's really not any positive or negative trend going on. There's just totally scattered of the points. I could not label it positive or negative. Okay, we got them all. Okay, it says you first make a scatter plot using heights of several women as the x-axis and their weights as the y-axis. The scatter plot indicates positive linear trend, so you calculate the R value. So you've done everything in the right order here. You have made a scatter plot, x, y. You've seen a positive linear trend between, it says, height and weight. And then it says you have all of the women wear 2-inch heels. So imagine what that's going to do to your graph. It's going to move all the heights over 2 inches. Is that going to change the R value? Well, no, it's not. Again, it's not going to change the strength of the relationship. All it did was move the relationship over to the right a little bit. So that R will be the same. Because it's the same relationship strength, just shifted. If you reverse your variables so that you have weight as your x and height as your y, again, it's going to reverse the points. It might make your line slightly in a different spot, but it's still going to be related in the same strength. So R will be the same again. Because it's the same strength in that relationship. And then finally, you collect data about women's ages and their average amount of steps. You calculate the correlation coefficient and it comes out as R equals 0.8024. What can you conclude? You have to be very careful here. You've missed an important step. He says you immediately calculate that correlation coefficient. So what we are missing here is we don't know whether this was actually a linear relationship or not. We need to look at a scatter plot first. So what can we conclude right now? Nothing. We can conclude nothing. I can't say this is a strong relationship or a weak one because I don't even know if it's linear. Okay, the rest of our example